Section 2.7, Division of Fractions and Mixed Numbers. Let's start by talking about the reciprocal of a fraction. The reciprocal of a fraction is the fraction with the numerator and denominator interchanged. So basically you just flip the fraction upside down. An example would be the reciprocal of 2/3 is 3/2. What happens if I ask you to find the reciprocal of a whole number? For example, what is the reciprocal of 5? Remember that any whole number, or any integer I should say, can be written as a fraction by placing it over 1. So technically the number 5 is 5/1, so the reciprocal of 5/1 would be 1/5. So like I said, because 5 is equivalent to 5/1, the reciprocal of 5 is 1/5. Example, let's divide 3/7 by 2/3. So 3/7 divided by 2/3. The very first thing I want to tell you about division of fractions is that you do not, I repeat, do not cross-reduce when you see that division symbol. You cannot cross-reduce when you're using division. In other words, you may be tempted to cross-reduce those pesky 3's. We have 3/3, but I repeat, it's incorrect. Never ever cross-reduce when you are using division or when you see that division sign. Here are the rules for dividing fractions. First, turn the problem into a multiplication problem by taking the reciprocal of the fraction after the division symbol. Once you do that, then change the division symbol into a multiplication symbol. The fraction that comes before the division symbol does not change at all. Once it turns into a multiplication problem, the second step is simply to multiply. And you're going to multiply in the same exact way as we multiplied the problems in section 2.6. Let's go back to our example. Using the steps that I just taught you, let's divide 3/7 by 2/3. Step 1 is to take the reciprocal of 2/3, which is 3/2, and then turn that division symbol into multiplication symbol. So now we have 3/7 times 3/2. Notice that the 3/7, or the fraction in front of the symbol, does not change. The next thing we want to do is look for cross-reducing. Now that it has become a multiplication problem, we can cross-reduce if possible. Can this 3 cross-reduce with 2? No. Can this 3 cross-reduce with 7? No. Can the fractions themselves reduce? No. So all we can do at this point is multiply. 3 times 3 and 7 times 2. So our final answer is 9/14. Example 2, 3/4 divided by 9/10. So first and foremost, let's convert the division problem into multiplication problem by taking the reciprocal of 9/10 and then changing the division into a multiplication symbol. We have 3/4 times 10/9. And you'll also notice here, I then, once it turned into a multiplication problem, cross-reduced. 3 and 9 can cross-reduce. They're both divisible by 3. And 10 and 4 can also cross-reduce. They're only divisible by 2. So we end up with 1 times 5 and 2 times 3, so 5/6. What happens if we have a fraction divided by a whole number, or division with fractions and whole numbers mixed together? Think back to what I told you about whole numbers or integers being mixed with fractions. Always turn it into a fraction by placing the whole number over 1. So the very first thing we're going to do is write it as 3/7 divided by 5/1. Then let's change the division problem into a multiplication problem by taking the reciprocal of 5/1 and by changing the division into a multiplication symbol. So at this point we're going to write it as 3/7 times 1/5. You next want to look for any cross-reducing possible. Can 3 and 5 cross-reduce? No. Can 1 and 7 cross-reduce? No. Are 3/7 and 5 1/5 both in lowest terms? Yes, they are. So our final answer is 3 times 1 over 7 times 5, which is 3/35. Let's try a division problem involving mixed numbers. 1 and 13/15 divided by 4 and 4/5. Again, because we're working with mixed numbers in conjunction with multiplication or division, we want to first convert them to improper fractions. 1 and 13/15 converts to 28 over 15. 4 and 4/5 converts to 24 over 5. So that's the very first thing you want to do. The next thing you want to do is convert the division problem into a multiplication problem. So write 24 over 5 as its reciprocal, 5 over 24, and then change the division into a multiplication symbol. So we're going to have 28 over 15 times 5 over 24. The next thing you want to do is determine if you can cross-reduce. 28 and 24 can cross-reduce. What's the largest number you can divide them both by? We can divide them both by 4. And then 5 and 15 can also cross-reduce. They're both divisible by 5. So, going back to 28 and 24, if we divide both of them by 4, we end up with 7 and 6. And then with 5 and 15, if we divide both of them by 5, we end up with 1 and with 3. So our final answer is 7 times 1 over 3 times 6, which is 7 over 18. The last example for this section is find the quotient of 12 and 3/5 and 7. The word quotient means division. So again, let's backtrack. The word sum means add. The word difference means subtract. The word product means multiplication. And the word quotient means division. So we're going to divide 12 and 3/5 divided by 7. Both numbers have to be converted. 12 and 3/5 has to be converted into an improper fraction, and then we have to take the whole number 7 and put it over 1. So 12 and 3/5 converts to 63/5, and then 7 becomes 7 over 1. Now we can convert the division problem into a multiplication problem. So take the reciprocal of 7 over 1 and change the division into a multiplication symbol. So now we have 63 over 5 times 1 over 7. The next thing we want to do is cross-reduce if possible. 63 and 7 can cross-reduce. Both are divisible by 7. And then 1 and 5 cannot cross-reduce, so you don't have to do anything with them. So 63 changes into 9 and 7 changes into 1. Our final answer is 9 times 1 over 5 times 1. So we end up with 9/5, or if you want to, you can convert it into a mixed number, 1 and 4/5.